Hi everybody, this is Mrs. Richardson and I'm going to be explaining to you guys lesson 9.5, which is about the fundamental counting principle. So in our previous lesson, you had to be able to find the number of possible outcomes in the sample space. And you did this by making a list, a table, or a tree diagram. But there's a faster and easier way to do this, and this is called the fundamental counting principle. And to do this, all you need to do is use multiplication, so it'll be much faster. So I'm gonna walk through the examples that are shown, and these are the same things that are in your book, and then we'll work through the got it problems together. So in this first example, it's asking to find the total number of outcomes when a coin is tossed and a numbered cube is rolled. So if you toss a coin, there are two options. And if you roll a numbered cube, there are 6 options. So to find the total number of outcomes, all you need to do is to multiply. And then you would get 12. So there would be 12 total outcomes in the probability experiment. Or you could say that, 12 total outcomes. We'll leave it at that. And down below, they show a tree diagram just to kind of show that here are all of the different outcomes in that sample space. But if you guys use the fundamental counting principle, then you don't have to do a tree diagram because you can just multiply to figure it out. So in this got it example, it's asking us to find the total number of outcomes when choosing from bike helmets that come in 3 colors and 2 styles. So you're going to choose a bike helmet and you're choosing between colors and you're choosing between styles. And for colors, there's 3 options to choose from. And for styles, there's 2 options to choose from. Multiplying those together, we get 6, so there would be 6 total outcomes. I also kind of like to think of the outcomes as possibilities or combinations. The next part of this lesson is finding probability. And in this lesson, it shows you how to use the fundamental counting principle to help find that probability. So in example number 2, it's asking us to find the total number of outcomes rolling a number cube, and it's labeled 1 through 6, and choosing a letter from the word numbers. And then we need, so that's one part. One part is finding the number of outcomes, and then we need to find the probability of rolling a 6 and choosing an M. So let's look at the first part, which is finding the number of outcomes. So on the number cube, we know that there are 6 options. And then for the letters, so this is where it's tricky. You guys have to look at how many letters are in the word numbers. There's 1, 2, 3, 4, 5, 6, 7. So this is where the 7 comes from. So when you multiply, you get 42. So that means that there's 42 different outcomes. So that's one part of the answer. The second part now is asking us to find the probability of rolling a 6 and choosing the letter M. In here, it doesn't really mathematically explain or show. It's only kind of saying that there's one favorable outcome. One way that I like to look at this is, I'm going to move it over here. So this is on your cube. And what was the other thing? This was the letters. And on the cube, we want to land on 6, and on the letters, we want to choose M. So I like to think of this more as like a probability, like a fraction. So on a number cube, the probability of landing on a 6 would be just 1 out of 6. And then for choosing an M, there's out of the, and remember, for the letters, it's from the word numbers. So we only see one M, so the probability of getting an M would be 1 out of 7, because there's 7 total. And then you can multiply them. So remember, when you multiply fractions, multiply across the top. 1 times 1 is 1, and then 6 times 7 is 42. So this right here is the probability. Okay, let's go to number 3. So number 3 is asking us to find the number of different genes available at the gene shop. So this is asking us to find the number of outcomes, which we can do by multiplying. And then find the probability of randomly selecting a 32 by 34 slim fit. And then, is it likely or unlikely that it would be chosen? Okay, so this actually has 3 different parts to it. So the first part, for the number of outcomes, remember, all we need to do is multiply. So here they give us a chart. So for the genes, we're choosing from waist size, which it looks like there are 5 of them, which is where they get this 5. Then we're choosing from length, which is 3 options. And then we're choosing from style, which is 3 options. Multiplying that gives us 45. So this is the number of outcomes. So this part's done. Then it's asking us to find the probability of choosing a specific size. So for the size, it's going to be a waist size of 32. Let me see, where can I work? I'm going to work over here. So it wants us to find the probability of choosing a 32 by 34 slim. So if you guys look at the chart, the probability of choosing a 32 waist size, that would be 1 out of 5. And then the probability of choosing a 34 length would be 1 out of 3. And then the probability of choosing a slim fit would be 1 out of 3. And then if we multiply those together, we get 1 out of 45. So this right here is the probability. And then it's asking, is it likely or unlikely? So to figure that out, it's easier to think of it in terms of a percent. So right here it says that 1 out of 45 is about 2%. So 2% is very unlikely that it'll happen. So when we're talking about how likely things are, usually it's like, here, I'll write it down here. If there's like a 0% chance, then it is impossible. And then if it's 100, if it's 100% chance, then I'm trying to think of what your book called it. Hang on 1 second. I'm looking so that I don't give you guys the wrong wording. Oh yeah, if it's 100%, then they call it certain. Like, so for sure it's gonna happen. And then if it's 50%, then they call this as likely as not. So 50-50 chance, like you have it's as likely for it to happen as it is unlikely that it'll happen. And then anywhere in between here would be unlikely. And then anywhere in between here would be likely. So this kind of shows you, using percentages, how you can interpret it into words. Okay, so let's go to B for the got it. So this says that 2 numbered cubes are rolled. What is the probability that the sum of the 2 numbers on the cube is 12? How likely is it that the sum would be 12? Okay, I'm gonna erase me see. I'm gonna erase this right here so that I have some room. Okay, so we're choosing two number cubes. So here's number cube, and here's a second number cube. And we want to know that the sum is going to be 12. So that means that when we add up the numbers, that it will equal 12. So remember, a number cube only has the numbers 1 through 6. So we need to figure out what are the different combinations that could equal 12. So if I roll a 1 on my first number cube, there's nothing I can get on my second number cube that would be big enough. So I would need 2 and 10, which wouldn't work because there's no 10. 3 and 9 wouldn't work. 4 and 8 wouldn't work. 5 and 7 couldn't work because there's no 7 on that second cube. The only possibility would be to roll a 6 on my first cube and my 6 on the second cube. That's the only combination that would give us a 12. So the probability of getting a 6 on the first one would be 1 out of 6, and the second one would also be 1 out of 6, for a total probability of 1 out of 36. So a 1 in 36 chance, let me get my calculator, is about 3%. So this is very unlikely that will happen. And remember, to change a fraction to a percent, you guys just need to divide. Top number goes in first, bottom number you'll type in second, and then move that decimal 2 times to the right. Example number 4, it's looking like it's just like the other examples that were given, so I'm not gonna spend time doing that. And okay, so we can look at the guided practice problems together. If you guys feel like, oh, I totally understand this lesson, then go ahead and stop the video right now. If you want to just keep checking for your own understanding, keep watching, and we can work through these guided practice problems. Okay, so the first one is asking us to use the fundamental counting principle. So when you guys read that, just think, hey, I need to multiply. And we are tossing a quarter, a dime, and a nickel. So this is asking us to find the number of outcomes. So to do that, we're just multiplying. So when you toss a quarter, there's just 2 options or 2 outcomes. Same thing for a dime, same thing for a nickel. So multiply those together. 2 times 2 is 4, 4 times 2 is 8. So there would be 8 different outcomes. So the tricky part here is when it's asking for number of outcomes, your answer will be a whole number. When it's asking for probability, then that means your answer is going to be a fraction. Okay, number 2 is how many outcomes when you roll a number cube and picking a cube from 4 different colors. Okay, so when you roll a number cube, there's 6 different outcomes, and then we're going to pick a colored cube and there's 4 different colors. Multiply those together and we get 24. So 24 outcomes. So again, outcomes, whole number, and we get it just by multiplying. Number 3, we need to find the number of outfits that can be made from 3 sweaters, 4 blouses, and 6 skirts. So I'm gonna just do that part first. So we're looking for number of outfits, so you guys just need to multiply. 3 times 4 is 12, and then 12 times 6 is 72. So there's 72 different outfits. Then we want to find the probability of selecting a particular sweater, blouse, and skirt outfit. And is the probability of this event likely or unlikely? So for choosing a specific sweater, it would be a 1 in 3 probability. For that blouse, it would be 1 in 4. And for the skirt, it would be 1 in 6. So choosing that specific combination would be 1 out of 72. And that is about 1%, which tells us that it is very unlikely for that to happen. So takeaways that you guys need to remember. Fundamental counting principle helps us find the number of outcomes, and all you need to do is multiply to figure that out. And then if it's asking for probability, remember, whenever it's asking for probability, then that means that your answer needs to be a fraction. If you guys have any questions,